The next thing we're going to talk about is gas pressure. So, pressure is the force exerted by gas particles colliding with the walls of a container. So, technically, the definition of pressure is force per area, or something like a Newton per meters squared, although that's not what we're going to measure it in. But the idea here is that gases cause pressure because gas particles are constantly moving randomly in all directions. So when they're moving, they will collide with the sides of the container, and that creates pressure. And the more often they hit, or the more particles are hitting, the higher the pressure is. The other thing about pressure is that atmospheric pressure is around us at all time. So air has mass and it exerts a pressure on everything, which I don't know. I also have this feeling when I teach this of like being oppressed by the air, right? It's just everything's falling down on me, but that is what atmospheric pressure is. And depending upon what level you're at, you'll have a different amount of pressure upon you. For example, standard atmospheric pressure at sea level is 1 atmosphere, which is our SI units for pressure. But this is also equivalent to 760 millimeters of mercury, or 760 torrs. So just some examples of this idea of pressure inside and pressure outside. When you're inflating a balloon, you are putting moles of gas. I was trying to think if I was allowed to use those words yet. Yes, I am. You are inflating a balloon by putting gas inside, which is putting moles of gas into the balloon. And as you put more and more moles of gas in, they are going to hit the walls more and more frequently, increasing that internal pressure and causing your balloon to inflate. And this internal pressure is going to keep the balloon inflated. When you think about the pressure in the human body is always experiencing that external atmospheric pressure. But we have internal pressure from fluids and gases. And these pressures are balanced, so no net pressure is felt. So it's hard to kind of understand this atmospheric pressure because our human body is always at this balance point. So we don't actually feel the atmospheric pressure. I mean, unless you start diving deep into the ocean or something. So I just wanted to show an example, which is called the crush can demonstration, to show you that we can crush a can using atmospheric pressure. So I'm just going to turn this guy on. I'll just maximize it. Where's play?
Low pressure inside the can and high atmospheric pressure outside the can. The atmospheric pressure is going to try to push and equalize those two different pressures. But it'll have to push on the water that's in the beaker and try to push the water into the can. Since water can't flow that quickly into the can to equalize those pressures, we're going to see the can actually get crushed under the pressure just from the atmosphere, the pressure that you and I live under every single day. 3, 2, 1. Low pressure inside the can and high atmospheric pressure outside the can. The atmospheric pressure is going to try to push and equalize those two different pressures. But it'll have to push on the water that's in the beaker and try to push the...
I won't make you watch that twice. Okay, so the idea here is that water was heated and it formed a gas, right? A steam inside of the can. And then when you cooled it, that steam inside the can condensed, so there was fewer gas particles, and then the internal pressure was decreased. So then the external pressure from the atmospheric pressure became greater than the internal pressure, and the can imploded or was crushed. Awesome. Okay, so what do we need to know about pressure? Well, in a lab, you can measure pressure in 2 ways. We can use, well, not in a lab, I guess. In the lab, we only use the manometer. But you can measure pressure 2 ways. You can use a barometer, which measures atmospheric pressure. And the way that this works is it uses a mercury column. And the higher the column, the higher the pressure, because you've got the atmospheric pressure, like Shouldn't be filming this early in the morning. You got the atmospheric pressure going down, and then it's forcing the mercury up the tube. And so the higher the pressure pushing down, then the higher the tube will go, or the mercury in the tube will go. You can use this for weather or altitude for trying to figure out the pressure of the atmospheric pressure. Versus a manometer, and a manometer is used to measure gas pressure in a container. So you can compare gas pressure to atmospheric pressure. So you could have atmospheric pressure, and then you add a different gas inside, and then the level of the mercury in the tube will change depending upon what the pressure of that gas is. Now, we're not going to have to worry too much about pressure of gases, except that we're going to be using it a lot in calculations. And you're going to be responsible for the SI units of pressure. So we're just going to make sure that you remember how to do dimensional analysis. And we're going to convert from atmospheres to millimeters of mercury to atmospheres, and then some random units like pascals to atmospheres, or millimeters of mercury to kilopascals. So the way that we're going to do this is we're going to use our formula sheet. So I'm going to split my screen here. There it is. Okay, and then I'm going to go down to this page. So I'm looking for this table. Okay, and then I'm going to zoom in on it a bit. Okay, so these are our different units of conversion. So if I want to go from atmospheres to millimeters of mercury, I'm going to set up a dimensional analysis. So I'm in atmospheres, and I want to get rid of atmospheres. So I'm going to put atmospheres on the bottom, and then what I want is millimeters mercury. And then you're just going to use this chart to see that millimeters of mercury is 760 millimeters of mercury for 1 atmosphere of pressure. So I'm going to put the 1 with the atmospheres, and I'm going to put the 760 with the millimeters of mercury. Now, just a note about sig figs. This 760 is not 2 sig figs. These are exact. Like the 760 especially is an exact value, so don't factor it into your sig figs. So we're going to go 1.13 times 760, and we get 858.8. And so we're going to answer to 3 sig figs and say this is 859 millimeters. Sorry, I forgot which one I was going to. Millimeters of mercury. Okay, if you've got this, feel free to pause the video and give these a go. Otherwise, if you're not quite sure yet, keep watching. So for this one, we're going to go from millimeters of mercury to atmospheres. So the difference here is that this time, the millimeters of mercury are going to go on the bottom, and the atmospheres are going to go on the top. But still, 1 atmosphere is 760 millimeters of mercury. So this time I'm going to go 1.68 divided by 760, and I end up with 0.00221 to 3 sig figs, and this time I'm in atmospheres, which of course, if you wanted to, you could put in scientific notation, and it would be 2.21 times 10 to the negative 3 atmospheres. All right, last 2 down here just for fun. If I want to go from pascals to atmospheres, I'm in pascals, so 5.0 times 10 to the 2 pascals. And I want to go from pascals to atmospheres. So I'm going to put the pascals on the bottom so that those units cancel out. And then I'm left with atmospheres. Now again, it's going to be 1 atmosphere, but this time it's equal to 101,326 pascals. So 101,326. So then I'm going to type into my calculator 5 EXP or EE or whatever button you want to hit there. 2 divided by 101,326, which is going to give me 4.9 times 10 to the negative 3 atmospheres, right? Or 0.0049, whatever you floats your boat. Okay, last one. We've got 291.4 millimeters of mercury, and I want to convert that to kilopascals. So I'm going to put the millimeters of mercury on the bottom. I'm going to put the kilopascals on the top, and I know that the millimeters of mercury is 760, and the kilopascals is 101.326. So this time into my calculator, I'm going to type in 291.4 times 101.326 divided by 760. And again, I'm not going to consider the 760 in my sig figs because it's exact. So I'm going to go to 4 sig figs. So I'm going to have 38.85, and this time I'm in kilopascals. Awesome. So that is what we're going to have to do with work with pressure, is just being able to convert between units.